Hey everyone, let's try another walkthrough for the Module 3 assignment. I guess the great thing about this, there's not a lot of Excel work necessarily, but uh, the content is a little more confusing. So I'll let you just kind of think about these problems up here a little bit as you go through everything that we've got. It's really, these are tricky. You just got to figure out the right technique to use for some of them. Let's just start with number 7. I think you could probably do this, but we'll walk through here really quick. We're going to flip a coin 8 times, figure out the total number of elements or sample points in the sample space, and then using Excel, we'll create a table of 2 columns showing the number of heads in one, and and then 8 tosses and the number of tails in another, and then we'll get some extra stuff in here. All right, so we're going to do 8 coin flips, then answer some questions. Let me go. Today I'm going to actually use, just mix it up a little bit, just use Google Sheets. This is, again, just kind of mixing it up to show you can do a lot of different things. This should be exactly the same on Excel. There's nothing we're doing here that's specific to anything. So Google Sheets you can access through your Google Suite and IC email and stuff. All right, so we want to get the sample size, or what we've been and the number of sample points. One way we can do it is we're flipping a coin. There's 2 outcomes. Again, try to use this for other questions too as you kind of work your way through that. There's 2 outcomes, and we're going to do that 8 times. So using that basic rule of counting, the 2 outcomes that can happen, we're going to take that to the 8th power. So we know that we'll have 256 different unique outcomes that could happen. Imagine flipping our coin and figuring out how many heads, how many tails are going to happen. And then the next part is really just going to be, let's characterize what those look like. So what are some of the different options that we can get? It's possible to get 0 heads, 1, 2, 3, all the way to 8. All right, so these are and we want to essentially just say, instead of writing them out, since we know that there's 256 different ways, we can kind of say, okay, well, how many ways can I get 0 heads? How many ways can I get 1 head? Since we're flipping our coin 8 times, if I get 0 heads, I know that corresponds to 8 tails. So I could also do 8, 7, 6, 5, 4, 3, etc. But I could do here also, I could just say, take 8 and subtract off the number of heads, and that'll tell me the number of tails. And this one gives us a nice autofill, like you probably are familiar with Excel and other things, but here's our autofill that we've got here. I thought I hit it, but if not, we can just copy and paste to get that taken care of. All right, now I think what we do next to make our table, the question's asking for is how many different ways, right? And so what we're looking for here, this is like the frequency, the count, something like that. So we can use that frequency or count, try to stay familiar with the language we've been using. So how many different ways can we do this? And we know this first one too, so this is nice. There's only one way where we get 0 heads and 8 tails. There's only one way to do that, where you flip a coin 8 times and you get all tails. So we know there's only one, but it gets a lot more complicated as we increase the number here. So I need some way to do this one, right? And hopefully this question that we're asking, like how many ways, right, can I flip a coin 8 times and get 0 heads, sounds like combinations. Like the order doesn't matter, it's just asking how many ways can we do this. And since it's combinations and we're using a function here, let me make it just a tiny bit bigger, we know we're going to use our comban function. And this function, again, it's really nice. These are similar between Excel and Sheets, so this should work for for Excel too, but you can kind of see how the function is exactly the same. The combin, it's out of the total number, and then we want usually the smaller number, I think. So we're going to flip the coin 8 times. So I'm just going to use an 8 there. And then how many am I looking to get correct? There is a similarity here, a symmetry that's happening that you'll kind of notice with this. But we could use the 0 or the 8. That would give us the same answer, right? Because if you think about it, how many ways can we flip a coin 8 times and get 0 heads? How many times can we flip a coin and get 8 heads? That's similar. There's only one way to do that. So it doesn't matter which one we pick. If it's the heads or the tails number, it should give us the right number. Okay. And then we've got the autofill. I'm just going to try something here and see if this works on Sheets 2. Just like in Excel, if we double click on this, if it autofills, and it does. All right. And now we've got our answer to our questions that we've got here with the different counts. And notice how it's symmetric. Notice how these are mirrored to each other as we go up. So the same thing, 3 heads, 5 tails is the same number of ways of 5 heads, 3 tails. There's that symmetry that exists. We know if we add these up, the total number of ways that we have here, we should get 256. We figured that out before. We made that calculation that we had, so that should be good to go. So 256. And then our last thing that I think our question asks is to calculate the probability, which is like the relative frequency of these happening. There's 256 different things that can happen, possibilities, and this is telling us like the likelihood of those that we've got. And so here, if we want to calculate that probability, it's going to be equal to, this is the relative reference right here, it's 1 out of 256. And then if I want to create this right here, the 256 is going to stay the same. That's the same denominator that we've got. So I'm going to use F4 or let's see. Since I'm in Sheets, F4, Command T on Max, and that's going to fix that right there. We can autofill. So we should get some values like this. Let's clean them up a little bit. You can make them percentages if you want to. Actually, that cleans them up pretty nicely. Okay. All right, so there you go. Pretty straightforward. We've got our probabilities. I think there's a couple questions we can go back and check and see what these look like. What's next? All right, so I think we got this. Fourth column, compute the probability. Third column, I think we've got the count. What's the probability of obtaining at least 1 tails in the 8 flips? So these are kind of interesting questions. What's the probability of obtaining no tails in the 8 flips? We can get that one. What's the probability of obtaining at most 4 heads? So we're looking at least 1, then no tails, and then at most 4. All right, so I don't know if I'll remember those, but at least 1 in the 8 flips. We'll come back here. Okay, so at least 1 tails, I think. Tails at least 1 is greater than or equal to 1 that we're looking for here. All right, how can we calculate this one then? So at least 1 tail. All right, so we can start here. These are our tails. So it means 1 tail, 2, 3, 4, 5, 6, 7, 8. So what we could do, right, is just add those up. That's all we're going to do here. So equal to sum, everything that is consistent with that. So here, 1 tail, 2, all the way. Pretty likely that you get at least 1 tail. That's a very likely occurrence at over 99%. But I want to show you a trick with this one too. Notice how on this one we can actually do we can use that idea of complements, that at least 1 tail is the complement for at least 1 tail. If the complement is like the opposite, right, is 0 tails, which is what the next question is going to ask us. So notice that if the question here is at least one, so it's saying, okay, what's the likelihood you get one of these versus the opposite of that, which is no tails, the complement. So if you remember to find the complement of something, we can just take 1 minus, and this is just like a faster way, kind of a shortcut, more intuitive way, so you don't have to add them all up. But you'll notice that we get the same answer, right? Is that we're just saying, okay, well, this is the opposite of this one, so adding up all these, and you add this together, it has to all be 100%. All right, so you can use that little trick for the complement, just take 1 minus everything else, and to get that answer there. So that's our A. All right, B, let's see what it looked like. B was, I think, no head, no tails. All right, probability of no tails. Let's do this one really quick. That should be easy. We know that the probability of tails equals 0. So the way we can describe it is just going to be that one right there. No autofill needed here. The last one, at most 4 heads. I think it said that. I'm just going to check it. At most 4 heads in the 8 flips. So at most meaning 4 is included in this particular case that we have here. So in this case, that heads less than or equal to 4. No good tricks here, but we'll just add them up. Here's 4, 3, 2, 1, or 0. At most, you're going to get 4, no more. So we could do the sum starting here, going down. All right, and that's C. Now the last question is asking kind of a neat, intuitive question where the probability of exactly getting half is declining. So if we flip a coin, one time, we know the probability of getting heads is a half. If we do 4 tosses, right, it's 3/8. Or if we do 2 tosses, it's a half, and it's declining. Here we can see exactly half of our last one that we had here. Notice getting exactly half heads is about 27.34%. So I'll let you kind of think about why that's happening as we increase the number of coin flips. Why is the probability of getting exactly half declining? Like, what's happening here? And what I want you to think about is, just think about how we're drawing this right here, the 0 to 8. That's getting bigger as we, flip more coins. And so that might mean what we're doing is we're spreading that probability distribution across more outcomes. So one thing that's kind of consistent, like we could make a chart right here. If we take the chart of this, you'll notice that right in the middle is the highest probability, but it's not even, right? That's because we're spreading those outcomes or that probability across more outcomes that we can have here. If you graph, this is kind of an interesting graph. We can do this one really quick. It's not necessary for you to do it, but a nice quick bar plot is a pretty good demonstration to kind of see what's happening. Let me see if I can move it here. Get it out of our space. All right. So there you go. All of these kinds of problems are going to look the same. It's declining as they get bigger, but just imagine the thing is you're spreading it out. It's getting wider, right? So as it gets wider, that distribution's spread out over more things, but it's still centered right in the middle. All right, so I hope that one helps for that question there. And then let's take a look at another one here really quick. All right, I want to do one more here. Let's do this health insurance question. Let's just get you the answers just to show you really quick how this one kind of works. I don't know if this will be an easy one. I just want to copy and paste this over to my sheet just to make it a little bit easier here. We'll see if it works. It might not paste very nicely or at all. Oh, it kind of works. All right. So we got our sheet here. it's easier just to get this. This is the thing that you'd always have to do with Excel is just, get this in the right format, if that makes sense. Get it someplace. I'm gonna put these in the middle, make it read it a little bit better. All right, do a quick check too to make sure recording okay. Yep, doing good. All right, so for this one, I would get it into a format like this, just so it'd make it a little bit easier to play around with and do some of the work. You can copy paste into Excel too. Again, nothing we're doing today can be done in Sheets. This is just a way to kind of mix it up to show you some different ways to do it. Okay. All right, what I'm going to do next actually is I want to get my table. I'm going to copy, I'm just going to create a new table, and then I'm going to get rid of the data inside here. And then I'm going to put my marginal probabilities over here. I'll call this total, and I'm going to put a total column down here as well. And we could do that up here if we want to too. This is not a bad idea, just to kind of add to our table a little bit. We're going to sum across these two. We can go ahead and use the autofill here. I don't need that one. Yet, I guess. And then we can sum across the columns. You can copy and paste. Here you can paste. It doesn't really matter if you sum across or up and down, but you can see that we got 2,000. I have to fix these here again. But we got 2,000 cases to work with. Case here. Bold these up just to make a match. I need to change the font size a little bit too. You don't have to do that. It's just make it look the same. All right. I'm just going to go ahead and do that really quick to make sure it's all matching. Change everything. Okay, so we've got our table, we got our raw numbers that we have right here, and we want to create the table. And with the table, we want to create the relative frequencies or percentages, probably to just kind of make it a little bit easier to work with. All right, so this is kind of a clever way to do it, a clever approach to give us the values that we're looking for. So we know that there's 2,000 total. So this is the total across everything. So there's 2,000 total. If you remember the way we would read this, right? These are 18 to 34 and 35 and older. So age is over here on the rows. So there's 920 people, 18 to 34, 1080, 1,080, 35 and older. And add those together to get 2,000. Then here on our columns, we've got, if they have health insurance or if they don't have health insurance. So here, 1,700 have health insurance, 300 do not have health insurance. That's how we kind of read our table. And then these are the interior, right? These are those joint probabilities we've kind of talked about that we've got before. All right, so what I want to do, we're just going to do an equation here, and we should be able to copy paste this one too, kind of like we did for the last example. We're going to take the first cell that we have right up here. We're going to take 750. We want to make this a relative frequency, so we'll divide by the total. And again, use your F4, your function F4. Command T if you're in Excel and Mac to fix that one, because we want to divide each of these by 2,000. Yeah, the fixing function is a really nice thing. If you don't want to do that though, we know there's a lot of different ways to do that. The same thing is just to write your equation like this. Just divide everything by 2,000 since it's going to be the same. We can use the autofill here. Actually, I'm just going to fill these in. Copy, paste. Don't really have to do too much. Once we do that first one, it's enough to do everything. Okay. All right, so now we've got our table. It's all set up. If we want to, we could make these percentages, which would make sense. Kind of put it like this. And then you can start answering some of the questions that are on here. Let's see. I'll let you kind of do that. I'll let you kind of work through these now that you have these, but be careful. Maybe we will work through one of these here. The joint probability table for these data and use these. Okay, so the joint probability table is what we just did. You can see this is the joint probability table. We've got all of our information right here. And then just so that as you work through here too, because some of these are tricky, what do the marginal probabilities tell you about the age of the U.S. population? Well, you can kind of look at that again if we go back. We have a few more older people than younger people, right? 54% are 35 and older, while 46% of the sample are 18 to 34. So that's what we're looking at there. It's just favors older people a little bit. What is the probability that a randomly selected individual does not have health insurance coverage? You're looking at that, what we would call a marginal probability in this case. So here's the column that don't have health insurance. So you're going to go look right there. So it looks like I hope you can use this as a check, that you can show that you can do this on your own, since your exam will ask you to do a question like this. We can see here, if we're looking at this, 15% don't have health insurance. Okay. If the individual is between 18 and 34, what's the probability that the individual does not have health insurance coverage? All right, so now we want to look specifically, right, for a particular group. So first off, we're just going to look at those that are between 18 and 34 of that group, right? So this is why I want to kind of go through here. This is that conditional probability. What is the probability that the individual does not have health insurance coverage? And that's kind of the question that we're trying to look at. Okay, so if the individual is between 18 and 34, so we're conditioning on that. So given that they're kind of young, what's the probability that they do not have health insurance coverage? Okay, so this is a good one to kind of work through. All right, so this is going to be the probability, like no insurance. I'm just going to kind of create a abbreviation here for us. It's the probability they don't have insurance given they're 18 to 34. Sometimes this is tricky for students, actually, and this is actually it's very tricky. You just got to be careful with the language. So given that second part, right, given that they're in the 18 to 34 group, what's the probability that they don't have insurance? Okay, so here what we're going to do is we're just limiting ourselves to this row. 46% of our individuals are 18 to 34, and then we're going to see 8.5% right there don't have insurance. So 8.5 divided by the 46% that we have here. All right, so given someone's in the 18 to 34 group, the probability they don't have insurance is about 18%. Okay, so hopefully these, again, it's the language, it can be confusing, but these are excellent questions that we want to answer, right? So we want to know if you're in that younger group, what's the likelihood that you don't have insurance? Okay, so that was that one. All right, if the individual is 35 or older, what is the probability that the individual does not have health insurance coverage? So we're doing the same thing, right? Asking that same question, except we're changing up the age group. All right, so back over here. So now what's the probability that someone doesn't have insurance given they're 35 and older? All right. So now we're just going to limit ourselves to this group. So there's 54%. And of that 54%, 6.5% don't have insurance. All right, so I'm going to use Excel to get that calculation. So that particular group, only looking at the older people, only 12% of the 35 and older don't have insurance. So here's what we would start to use to say, okay, that's a different, comparing those two groups that we have right there, these conditional probabilities. This is probably consistent with what we think of in the real world too. Now, we're flipping our conditioning argument a little bit here. If the individual does not have health insurance, what is the probability that the individual is in the 18 to 34 group? So now we're saying of those people that don't have health insurance, what's the probability that they're in that younger group? All right, so let's go back and do that last one that we have right here. So now it's saying, okay, given that you don't have insurance, what's the probability you're 18 to 34, given that you're in the no insurance group? So we're just kind of flipping that a little bit. Here's our no group, so now we're conditioning, we want to just look at this case right here, the 15% that don't have health insurance. How many are in that no group? All right, so equal to the young group divided by the total number in the no insurance group. All right, so 57%, and we could use that again to see. But this just is typical. It looks like, you know, young people, and this is a typical result that we would see in the real world, that young people aren't going to have and often don't have health insurance. Not at a huge rate, we can see from our data right here, but young people typically don't have insurance as much as older people. Okay, all right, I hope that makes sense. You can answer that last question then too about it. What do you get out of this? That's an interpretation on your part. Hope the rest goes well. Again, this is work through some math stuff with those guys. All right, good luck. Let me know if you have any questions.